So we're going to talk about CORS. You should be able to see the slides now. If you don't, you're not going to be able to tell me. So cross-origin resource sharing, and this is me. Now, you've probably all seen cross-origin sharing before. Oh, apparently you don't see the slides. Let's try this a different way. So that should work now, right? Okay, thank you, Nick. So cross-origin resource sharing. Generally what happens is you do stuff on the web, and eventually you get a nasty error message from your browser saying, no, you can't do that because cross-origin resource sharing. And then you go to Google, Stack Overflow, and then you get some helpful people telling you this. So you look for what is CORS, and it's when you add access control allowed headers star to all the requests and responses from your web server, and then your website works. Hooray, everything works. That's a terrible idea. But unfortunately, it does work. So this is an answer that you sometimes see on Stack Overflow with the most votes because it works, it's simple, but it's kind of dumb. So I thought to really understand what CORS is, we need to define what it actually means. So I think we can think of CORS as a standard that permits the browser to circumvent restrictions enforced by the same origin policy. So we've begun from one acronym of CORS to a second one, same origin policy. So what is it we're circumventing? And what are the restrictions of the same origin policy? So we actually need to understand that as well first before we can even start thinking about CORS. So the same origin policy, it restricts how a resource from one origin can interact with resources from another origin. A resource you can think of as a JavaScript file, CSS, image, HTML, JSON, pretty much anything that a web server can respond. Now, what is an origin? Well, it's not just a domain. Sometimes people say cross-domain requests. That's not really a thing. We actually need to know about cross-origin requests. So origin is made up of the protocol, a fully qualified domain, and a port. So the domain is just one part of the origin. So what are some matching origins, or what is considered same origin? These are a bunch of resources hosted somewhere, and these have matching origins. So they're all HTTPS, the protocol is the same. The fully qualified domain name, www.mywebsite.com, is the same between all of them. And they all have the same port, which is port 80. You don't see it, but it's hidden. And there's a bunch of different example resources in there. Those can all interact with each other. Here's some cross-origin URLs. First two. The main difference here is that the port number is different. The second one has port 3000, the first one has port 80, but everything else is the same. Our third example, we're now using HTTPS instead of HTTP. It's a big enough difference to make things go nope. Our fourth one, we have the subdomain of store. Now, this does not match the first URL, even though the protocol and the port could be the same. This is a little bit different to the behavior of cookies. Cookies will allow you to specify a wildcard subdomain to match an origin. But when we're talking about cross-origin resource sharing, no, it has to be an exact match. And lastly, hacker.com, it's probably someone else. We don't want to share resources with them or have their resources shared with ours. So that's the difference between cross-origin and same origin. So what are some of the restrictions? You cannot read contents of a cross-origin resource. So that could be something like a JavaScript file from one origin trying to read the contents of an image from another origin. Nothing too scary there. But we can execute cross-origin resource. Now, that's a little bit strange. Execute's allowed, but read isn't. And execute is a little bit of a strange word when you're thinking of a resource. We talk about execute in that the browser executes your resource. So an HTML file is executed in that it is rendered and displayed in the browser to the user. An image is basically just a bunch of bytes. It's executed and you actually see the image. CSS, the styles get applied to the document and then they look pretty. So execute means that they will run, things will happen. Read is more about sort of looking into the contents of it and trying to extract information from that. And we can partially send. So send can be things like post requests, put requests, things where we're actually sending information. So there are some cases where we can and some cases where we can't do that, but more detail on that. So why is it that we can't read? Because read's normally one of the safer things to do. Why is it dangerous? Well, let's imagine we have a secure banking system, yourbank.com, and you're looking at your account information. Let's also imagine that there's a whole bunch of good security on there. They've got authentication, they've got two-factor auth, they're super, super secure. And let's say we see a nice advertisement for free iPhones. We go visit their website because, it's free. And somewhere in the source of their website, they have an iframe. And the iframe points to the source of our bank account. So we can think of this as freeiPhones.com being one resource, the HTML file, trying to access another resource, the account info HTML file. Now, normally with iframes, you're able to actually grab a handle of the iframe, access the content window, grab the document, and then grab the inner HTML. Now, had these been on the same origin, this would have been permitted, but because we are cross-origin, this is not permitted. Now, you can imagine lots of bad, scary things happening. You could just start reading information about your bank accounts, stealing cookies, CSRF tokens, all sorts. Very dangerous. You can imagine another similar scenario with an image, actually. So let's say you have a secure image host. To embed that image into another web page would be permitted because we can execute it. But to read it, to actually look into the bytes, would be stealing the image and giving this information to someone else. So read is dangerous, even though it doesn't normally sound dangerous in terms of security permissions. So why is cross-origin execute no big deal? And why are we allowed to do it? Well, same scenario again. We actually did an execute already. So we're actually allowed to embed other resources, such as iframes, images, CSS, into our page and execute them. And that doesn't really matter too much because all that's happening is you're seeing your own bank account information. This is something that you're already permitted to see. So in terms of execution through the browser to the user, that's totally safe. But the other resources, which are not on the same domain, are not allowed to peek into it. So it doesn't hurt. Rare case where execution is safer than reads. So what is send? This is a little bit strange, but you can think of a get and a post. So these are permitted if you have query parameters. Now, a get being a send doesn't make much sense. You're doing a get request, you're not sending. However, if you have query parameters on this URL, technically you're posting and sending query parameter information to the sender. So that's considered sending data. Same goes for post. What you're posting is a JSON payload. Now, these are only permitted if you have no custom headers. So a customer header is anything that's not one which the browser sets by default when it's making a request. Now, we need to be careful with sends because the server is going to handle this request as normal. You're permitted to do the send with a get or a post. But the strange thing is that although the server handles the request, if it responded with any data, you're not going to be permitted to read that data, because this is breaking the rule of not being able to read cross-origin data. So you can send cross-origin as long as it's a get or a post with no custom headers. Now, why do we allow get and post but not put delete? Well, legacy reasons. In the olden days of the internet, we didn't have things like CORS or same origin policy. And you used to have HTML forms, which allowed you to make get or post requests. Or you could have a hyperlink, which is a get request with query parameters. So in the olden days, the browser would make those requests, not care what domain they were going to, and security vulnerabilities all over the place. So when this same origin policy was added, to not break the entire internet, they decided to permit these two as long as there were no custom headers. So cross-origin send for put and delete, these are not permitted at all. You can't do that, extremely dangerous. That's what they decided. I kind of would have liked to have seen get and post also forbidden, but yeah, we can't break backwards compatibility with the internet. So same origin policy can be a little bit annoying, especially if you want to work with other websites, share resources, or we have multiple domains which we own, hosting multiple resources, and they need to interact with each other. And this is where CORS starts getting annoying. Most people only start learning about CORS when they bump into these issues. And without having a full understanding of the single origin policy and what that stops you from doing and what you're permitted from doing, you can accidentally do things with CORS which you really shouldn't do. So one thing that we might want to do is allow everybody to read a resource. So an example I like to use is the bankholidays.json from Friendly Government. Now, one thing that we're allowed to do with this resource, because it's cross-origin, is we're allowed to execute the resource. So a way you could think of a resource being executed in the browser would be to spin up an iframe, point that at bankholidays.json, and the browser is going to go fetch that JSON for you, and it's going to execute it, and that it's going to render a representation of the JSON in the iframe. But that's kind of dumb. It's not very useful. So yeah, we can fetch the data, but we're not allowed to read it. And that's really what we want to do. We want to grab the data from the JSON and start doing things with it. So it's the server that returns the response with the resource that's in control of whether or not you can or can't do this. So all you need to do is you need to add a header on the response of that resource that says access control allow origin star. So this allows any other origin or any cross-origin request, take this resource and then to read it. And then, hey presto, we have something nice and useful. This is dangerous though, because now anyone can use this. And if you're hosting lots of files which other people are interested in, they're going to start treating you like a CDN if you do this. So careful with that one. Only to be used when you have something that you intentionally want everyone to see and share and execute and read. So let's say we want to restrict things a little bit more. Let's imagine a contrived scenario where we have a widget which can be embedded as an iframe into someone's website. Now, we know that we get execute permission for free, so this little widget can be useful already for any website. However, let's think of a scenario where we have some special customers and we want to give them additional features or information, tighter integration into the widget, and they're going to pay money to do that. Well, if we want these people to be able to read into the widget itself, maybe send some commands to do stuff or rip out data to get a really nice tight integration. We only want some people to be able to do that, but not everyone. So rather than doing a star in the access control allow origin, we can whitelist a domain. And this domain will be allowed to read the contents of the resource. So always, always, always do this if you can. And Something you're not allowed to do, which is a little bit annoying, is pass multiple values in the allow origin response. So you might want to have friends.com, some other friends.com, facebook.com, but no, you can only do one at a time. You must match exactly the origin that came in the original request. So this is a little bit annoying, but unfortunately that's how it works. So sending, sort of our last thing that's not really permitted. If you want to do a get or post with custom headers, normally which happens when you're doing Ajax, or if you want to do put or delete. Now, if you think before about the wild days where servers didn't verify requests at all from other domains, we need to make sure that the server is okay to actually receive these requests in the first place. Otherwise, the server is just going to go ahead and process that request, and it's too late. So just imagine someone wants to do delete.com/database. You can make the request. Server might do it. Who cares if you can't read the response because you've already deleted the database. We need to make sure whether it's actually safe to make this request in the first place. If you're only ever intending this request to come from your own website and then someone else starts doing it, that can be dangerous. Now, again, slightly contrived scenario, but kind of illustrates the point. So this is the pre-flight request, this verification step. So the browser makes an options request to the resource. So in this case, we make an option request to database.com, exactly same as before, but it's going to set some additional headers. So it's going to set an origin header describing, well, what was the origin of who tried to make this request? Is it someone we trust? Something for the server to evaluate. The access control requests method tells you what operation they were trying to perform. Remember, it could have been a delete, a put, a get, all of which might have different results on the server, some which may be allowed, some which may not. And then as well, we have all of the headers that were sent through that were custom headers. So this will be anything that the browser doesn't set by default, plus a few other really plain, non-interesting headers. Again, because the action may change based on the header. You don't normally think about this, but yeah, headers can be done, or headers can be used to make significant differences in the processing of a request. And lastly, we don't actually send the request body at all, because you don't want some dumb server client to just take the request and say, oh, there's the body, ignore all those headers and all that cross-origin stuff and just do the request. So no, we don't send the body because someone might just go process the request anyway. So what happens next? The browser has sent its request. Everyone in the browser sends a response. Sorry, the browser does not send a response. The server sends a response. Wrong word there. So we actually have to say what we allow. So we now have to say that we allow the origin that came in the original request, an exact match. So we have to have the protocol, we have to have the fully qualified domain, and we have to have the port. Port 80 is implied to be the default here. We have to say what methods that allow. Same as came in. Can you do get, post, delete? In this case, yes, you can. Options is not strictly necessary in this case, but a lot of people seem to think it's nice to have it there. You could make a request, which is an option request that requires a pre-flight check of its own, but that would be a very strange thing to do. But yeah, it's somewhat valid to have options in there, but it does not prevent pre-flight requests from being made at all. And you need to see what headers allow. So we know what requests we wanted to make. We've been told by the server what sort of options we're allowed to perform in the request. And if all those things marry up exactly, the browser is then happy and it will make the real request for you. If you get no response because the server doesn't listen to options requests, then nope, nothing happens. If everything doesn't match up perfectly, nothing happens. So this keeps you nice and safe. So cookies are interesting. By default, an AJAX request does not send cookies You can imagine a world where they were turned on by default. People would be sending cookies all over the place, and it'd be scary. And yeah, everyone would have been hacked by now. So to send cookies, you have to set the with credentials option on the XHR request to true. The moment you do this, you're going to require a pre-flight request to be made. And the server must then respond with the header access control allow credentials true. Otherwise, you're going to have a failed request again. So this is why AJAX requests normally don't have cookies. But most of the time, if you're doing anything to do with authentication or trying to prove someone's identity, you're going to want those cookies on there. So to summarize everything up, the same origin policy keeps us safe from resources, from other domains, doing nasty things to resources on our domain. Keeps you safe. And we also need to make sure that we don't think of pages or websites or domains. We're talking about origins and we're talking about resources interacting with each other. It's not your home resource versus the world. It's resources against each other and playing nicely. So CORS is what lets us relax security of the same origin policy when we need to, but we need to do this very carefully. Otherwise, you're opening yourself up for some pretty nasty vulnerabilities. And I quite like to think about the permissions that resources have as sort of read, write, execute, which is sort of the same sort of file permissions on Unix. Just think that if you could read, write, or execute any information on this resource from a different domain, would that cause problems? It's not really an intuitive way to think about it in any other way than this, I think. And most explanations don't have you thinking about the security that you're removing by adding CORS, but they're thinking about the feature that you gain by adding CORS. So what you gain is you gain the ability to make cross-origin requests, but you must not forget about security. Now, this is only browser security. So CORS is only going to protect resources from resources within the browser. There are a whole host of other techniques that we need to ensure that our servers themselves are safe. So CSRF is super important. Without that, you're open to many other attacks anyway. So this is purely browser. Remember, someone can just take a curl, make lots of requests to your server and start doing nasty things. So that's pretty much everything. Are there any questions? We have, is our app safe? I think so. It's quite hard to tell because security is very complex. By default, Rails gives us a lot of security at the box, which is quite good. So we have a lot of CSRF protection in there already. CORS is on by default. Where we're not 100% safe is when you're in sort of a microservice environment, and you need to make your requests from your client to a different backend resource, which might be a service. You need to add CORS support, and everyone's first instinct is to add that star in the allow headers, and yeah, that gets you the feature that you want, but you're throwing away your security. So be very careful. Make sure you absolutely understand the implications of adding CORS.